There is one expression that I particularly love: zoom out. I love to zoom out because it allows me to see the big picture and determine my position in the whole. Without this action, I feel like I'm lacking vision and orientation, and I'm kind of lost. I don't know what zoom out means for you, but for me, it means learning different technologies and paradigms than the ones I'm using, understanding the business side of the software I'm working on, or even identifying patterns in one discipline and applying them in different contexts. One way to zoom out is to shift our thinking from binary to spectrum. But there is another one called systems thinking, which is used in different fields, including software engineering. When applying systems thinking, you get a new perspective on how to build software projects, as well as an opportunity to reflect on your job from a different angle. Why systems thinking, you might wonder? Systems thinking is not just a tool or a methodology, it's a mindset that enables you to see beyond the immediate and obvious and to understand the intricate web of interactions within any system. It teaches you that every decision, no matter how minor it seems, can ripple through the entire system, influencing outcomes in a way you might not have anticipated. In software architecture, this approach is invaluable. It allows you to design and build software that is not only functional and efficient, but also resilient and adaptable. It teaches you to consider not just the code you write, but the ecosystem in which your software lives. A world of users, business goals, technological shifts, and unforeseen challenges. So let's have a look now at Peter Senge's 11 laws of systems thinking and some examples of how these laws manifest in the software development realm. In his book, The Fifth Discipline, The Art and Practice of Learning Organization, Peter Senge has focused on problem solving using systems thinking. He presented a set of approaches and methods that can be applied to any field that is rooted in human relationships. In the book, Peter Senge talked about 11 laws that we can use collectively to solve problems across different contexts. Law number one: today's problems come from yesterday's solutions. This law remembers us of technical depths which results from choosing easy, quick solutions instead of better approaches that would take longer. Law number two: the harder you push, the harder the system push back. Law number three: behavior grows better before it grows worse. Law number four: the easy way out usually leads back in. Law number five: the cure can be worse than the disease. Law number five refers to a hotfix or an implementation of a new feature that causes a regression in other corners of your application. Law number six: faster is slower. Of course, you know it, and you are not alone. Each one of us has worked in a project where 20% of the implementation time was spent on finishing all the requirements and 80% of it was consumed by bug fixes or performance optimization, resulting from unclean and spaghetti code or other flaws. Law number seven: cause and effect are not closely related in time and space. Law number eight: small changes can produce big results, but the areas of highest leverage are often the least obvious. Law number nine: you can have your cake and eat it too, but not all at once. This law means you cannot simultaneously retain your cake and eat it. In other words, you cannot expect to have two incompatible things. As an example of this, you can imagine a client who wants to optimize their web application performance and increase its accessibility at the same time. They asked you to offer the user the possibility to open and edit dialog by double mouse click on an item, click on the item, then press enter, navigate with the keyboard arrows up and down for the item, then press enter. Can you guess what's wrong here? Whenever you add more keyboard listeners, you should expect a decrease in performance. So keyboard listeners and better performance could be considered as two incompatible requirements. Law number 10: dividing an elephant in half does not produce two small elephants. Elephant is not just any old term. It's a metaphor to describe something that appears complex, but in reality contains a lot of individual parts and relationships between them. Law number 10 means that a piece of software that is built in a given context can't be separated that easily. Let's say that you have implemented a REST API or a library that is used later by different projects within your company. After a few months, you've noticed that you need to restructure the source code, give some methods better names, and carry on other changes. Whenever you want to update your library, you have to avoid regression in other projects, and you need to be aware of how this update could affect other systems. Even if there is a method that you want to delete as cleanup and it's used in an external application, you have to decorate it as deprecated without removing it. Law number 11. There is no blame. No matter what industry you are in, some problems can be solved better by zooming out and considering all related factors before diving into details. In order to be effective, you need to understand your role in the big picture. Asking yourself questions like, how do I relate to everything else? How is what I am doing affecting others? Allows you to understand the landscape and determine the right technology and products to build. With this in mind, I'll leave you with a quote that I hope will inspire you. The discipline of systems thinking is more than just a collection of tools and methods. It's also an underlying philosophy. Many beginners are attracted to the tools in hope that these tools will help them deal with the persistent business problems. But systems thinking is also a sensitivity to the circular nature of the world we live in. Excited about diving deeper into the world of software architecture? This video is just the beginning. Check out my Udemy video course on software architecture, where I explore these concepts further and dive into real-world challenges. The link to the course is in the video description below. And here is a bonus. Subscribe to my newsletter and you will get free access to all my courses. I cross my fingers to all of you and wish that your journey with software architecture will be a perpetual odyssey, and that you embrace every challenge as an opportunity to learn, adapt, and innovate. If you found this video helpful, don't forget to hit the like button and subscribe to the channel for more updates and tech insights. See you next time.